Good morning, and thank you for joining our webinar today on lead time to component failure and the impact on O&M strategy. I would like to thank AWEA for making this program available. My name is Byron Hyzak. I serve as Regional Sales Manager for the Americas, pretty big region. You may know us as Brüel and Kjær Vibro, but in the U.S. and Canada, we're typically known as D&K Vibro. We'd like to get a better feel for who you are. So if you could let us know about your background and those of you on the call. So we have a first polling question. If you could all take a look at that. We'll give you a minute or two to walk through that. Alrighty, thank you. I'd like to give you just a short introduction to D&K Vibro. We've been in the business for over 60 years. We are a global company, and we are pioneers in wind turbine condition monitoring for this industry. Our first CMS installation was installed in 1999. Since then, thousands have been installed and are monitored daily. Since BKV has gotten into remote monitoring to provide diagnostic services, our coverage has expanded to be global. We have a center in Houston, my favorite, easier commute. We have 2 centers in China, and our headquarters is located in Nærrum, Denmark. I'd like to give you a second polling question with respect to CMS in your wind fleet. Which one or which ones do you have? You can have multiple answers on this. Okay, thank you for that. I'd like to introduce your presenter for today, Rainier Hemmesen. He is the lead diagnostic engineer for the North American Remote Monitoring Group. He's been with D&K Vibro since 2009. He is a Cat 4 vibration monitoring expert. Rainier.
Thanks, Myron. And all of you out there, thank you for dialing in and participating. So I'm going to talk about lead time with you guys, but not in the sense that you think. This is a question I've been asked so many times by different people. You know, how many months can you guys provide? What is the remaining lifetime of my component? How much time do I have left? So on and so on. But that's not what I'm basically going to talk about. I'm going to take a little bit of a different approach to it and talk differently about it. But let's look at the overall picture of the value given by CMS when it is done right. So why do you want to do condition monitoring? If we do this correctly, we can avoid the catastrophic failures. We can avoid the bleeding towers, and we can do up tower repairs as opposed to down tower repairs. Now, sometimes down tower repairs are really necessary. You cannot avoid it, so you have to get that crane in. But through early detection, it means that that crane operation can be planned far in advance, and it can even be combined with other site-related works. Now, you got downtime reduced. I spoke with a gentleman last week here in Canada, and he told me every time he has to get a tech in from the OEMs, it takes him 19 days to get him in. And that was the biggest reason that he was at this event. He was looking for CMS suppliers to help him battle with these awesome downtimes that he's facing. Now, if you sum all of this up, you can actually increase the annual energy production or even improve it. And one of these things you can you can derate these turbines that are suffering mechanically when in high wind seasons or in high wind periods. So, lead time is somewhat of a subjective word in the wind industry today. And after working with both the OEMs and the owners and operators, the remaining lifetime of a drivetrain component is something that is not easily defined. So I started out with Wikipedia. And what do you know? It's the latency between the initiation and the execution of the process. So we say the initiation is the early detection and the execution is the replacement of that damaged component. In theory, these two parameters are of equal magnitude. Without the initiation, there is no execution, and without the execution, there is no need for the initiation. But however, in real life, things aren't always this easy, as both the initiation and the execution can go very, very wrong. So, what does lead time to failure really depend on? So we can say, okay, A, it depends on the component or the failure mode. And an example, it could be a multi-stage gearbox. The detection rate for different failure modes is quite different from stage to stage, and thus the lead time to failure is quite different. We're of course not interested in knowing when the component fails completely, because that would not exactly be proactive. You know, I've seen gearboxes run for 8 months with broken teeth, where no secondary damages is introduced. And I've seen the same thing happen in weeks, where the neighbor teeth and the gears just get completely blown out. So planning a good lead time or predicting a good lead time is something that is extremely difficult. We can also say that lead time to failure depends on the quality of the service provider. You know, what kind of information is it that they deliver? And maybe most important, do they deliver the information? You know, and here, you know, I'm talking about the data. Do you have access to that data, or are you just being gained access to words, so to speak, alarm reports or advices, or can you actually look at the data itself? See, if one fails, the value is almost lost in CMS. So the execution and the initiation, they need to be treated equally. And I got a little bit of an example of that here. So we got 2 parks, both got retrofitted with CMS. One, due to end of warranty popping up, I believe they ran this park with CMS and 10 months prior to end of warranty. And the other park has completely different, let's say it's different situations, way past warranty, but they both have the same goal here. They want to make improvements. So, in the first case, the park coming out of warranty, a fault was detected and reported, but it was not identified. We had to insist for another inspection, and this meant that precious time was actually wasted. But during that second inspection, that fault was actually identified, and the replacement was planned. But, of course, Murphy's Law, secondary damages occurred due to delay in spare part delivery. So it ended up actually to be a major repair with something that was discovered in its early stage. So what is lead time again? Is it when we're picking up that fault, or is it when that fault is being confirmed on site through that inspection? Something you need to think about. So in the second case, we had a fault detection, the inspection was done, the fault was identified, though it was minor at this time. But even though that replacement was scheduled due to limited access to site. So the replacement schedule was based on weather condition, if you will, and not on the remaining lifetime. So here we have different scenarios that can describe lead time in a complete different way. So again, what is lead time? So, when discussing lead time with our customers, we would often very much like to know who is on the execution side, who is that guy up tower, because very often lead time is not necessarily equal to lead time. We do this to better meet the expectations and to ensure that the overall maximum gain of the CMS value is there. We want to get the highest value possible of that CMS. So one story for you here is that I have a customer that does not have the equipment to perform borescopes inspection, which obviously is crucial for doing the early fault identification. every time a team is dispatched to do this borescope inspections, I think they have to pay out a minimum of 4,000 USDs. So it's not exactly cheap to get this early detection done. But I told these guys that I could easily find 10 candidates in their parks where I do actually suspect something. So it is extremely important when we talk about lead time, when we talk about early detection, that you actually do have the equipment to perform these things. If you're outsourcing the maintenance or the borescope inspection, so every time that the CMS specialist has a hunch, it's going to cost a lot of money, and you might even risk that nothing is found. And if nothing is found, then we all of a sudden this becomes a trust issue. And that's the last thing that you want between the owner and operator and the CMS supplier. You want to maintain that good trust and good relationship. So, what is the early fault detection? Now, there are fault signatures seen in the vibration data which cannot be seen with the naked eye. This could be subsurface cracks, for instance. This will cause load variation, which are being picked up by the vibration sensors. And very often, this could trigger the CMS analyst to even issue a report. But sending someone out to inspect for such a fault will only result in one thing: nothing found. Well, again, we wasted a lot of people's time, we wasted a lot of money, and for what? For that sake of that early detection. So it's not an easy decision when to make it, when to go out and really look for it. You really need, you need to know what you're doing here. Sometimes there are minor issues causing the system to respond, which actually can be seen by the naked eye, but often reported back as normal behavior compared to the gearbox age, such as particle drags and a little bit of scuffing here and there. This is considered normal. So when do we really talk about early detection? In many cases, the early detection is first confirmed if it's visible by the naked eye. But when we say a particle and drags are normal, then of course we can't really talk about the fault detection. So where's that dividing line between normal wear and tear versus the unhealthy state progression? So one case here. A part comes out of warranty. CMS is retrofitted prior to the end of warranty. Several turbines showed what appeared to be a fault signature. But when we went through the end of warranty reports, they stated no anomalies. So we went through all the borescope pictures, and we were comparing that with the vibration data. And it became very clear that distinguishing between the normal behavior and a possible fault condition is not something you find in your dictionary. But during that time, the data collected resulted in several up-tower repairs by the OM under warranty, which not only prevented major repairs, but also helped reduce unplanned downtime and thus loss of production. And as I said, lost production is often the greatest cost penalty of a wind turbine fault, and often the best argument for CMS. So, CMS can be a very strong tool to have when you're trying to optimize the different activities associated with these machines. And this could be priority of repairs, this could be better utilization of available resources, and this could be fast up-tower troubleshooting in terms of fault finding. You don't necessarily need to borescope the whole gearbox. You can go straight to that component that the CMS has identified. Planning and scheduling. Planning is just so important here. Even a skilled team does a poor job if planning is poor. And last, it helps ensure fleet meets and even exceeds the design life if you use it correctly. You got to use it. So I would like to ask you guys to put in your votes, because I'm very interested in knowing what are your major issues. Yeah, I don't think we have to see anymore. I think we all share the same issue here. It's the gearbox that's always teasing us. We should have broken that up. We should have broken it up in high speeds, IMS, and the planetary stage. Alrighty, thanks for that. I think we got a clear idea of what kind of issues we're all dealing with here. Well, you guys especially. So we'll move on. So let's look at how you can really use it, CMS in your different strategy models. We see different models popping up through different clients, whether it's the owners and the operators, whether it's the OEMs or who it is. So here's the one situation. We got everything in-house, from initiation to execution. The owners, they're monitoring, interpreting the data, as well as communicating the information to that maintenance crew. All is internal. No information is lost, or it shouldn't be at least, as all the data is accessible within that same organization. With that being said, I've seen many large organizations that are not very organized, but that's another story to tell. So another thing here, there's no conflict of interest, and the goal is just to get that early detection so we can provide that information to that execution team. One thing that maybe should be incorporated on this slide is in between the initiation and the execution, you can put your SAP system or whatever that you use, so you can get all the data to be flowing within your own system, so to speak, to generate work orders. When that work order is being executed and done, feedback can be automatically generated in that system, provided back to the CMS analyst. Everything is beautiful. Now, there is one possible downside to this model, and that is when you do in-house CMS, and that is if you have a large fleet of turbines, that CMS is a full-time job. Very often the CMS analyst or the responsible will have other responsibilities, and then sadly to say won't have time to look at all these alarms. So again, what's lead time? If you don't have time to look at it, you don't have any lead time. So that it starts really there. You need to have a dedicated CMS team, or at least CMS specialists that are taking care of this 24/7, because this is a full-time job. Another situation is when we talk about outsourcing models, if you want. So service provider A, service provider B, two separate service providers, no communication in between the two. Everything goes through the owner and the operator. So this could be the case for a small wind farm owner and operator who simply doesn't have the capability or the capacity to be self-performing. Now, the benefit there is he gets a larger CMS staff with years of experience that most likely has seen that problem before and are able to perform a very targeted recommendations. On the other hand, there's a good chance that that operator will not have the same insight and knowledge about their asset and how well they're performing or even breaking down, which is a crucial information to have if and when you're considering to insource CMS one day. Now, if we go for the third situation, kind of like a hybrid model if you want. So the owner has in-house maintenance strategy, but CMS is being outsourced. So the operator has full insight of what's going on with the turbine as the CMS communication is between the operator and the CMS provider. The initiation to the execution, the owners and operators, they review the CMS data provided, all the recommendations, and then make decisions based on the recommendations and put a plan of action into motion. Now, one possible downside here is that between service provider and owners, there might be some latency introduced. And what you want to make sure is that you've got a good local support in your CMS provider to decrease or even eliminate that latency in communication. It happens very often that we do not have time to send out alarm reports. We have to pick up the phone and call these customers right away because we believe that the situation is that severe. We simply don't have time to go through documentations online. We need to talk to these guys right away. So, one more polling question for you guys, because I'm quite interested in knowing what kind of strategy you're using. This is as I suspected. We're seeing an increasing trend where both actually applies. So that's quite interesting. thank you for that. So let's talk about a little bit about takeaways and key learnings here. So many warranty periods, they're only 2 years. During these 2 years, the responsibility of the turbine performance is held by the OEM. So when these 2 years are up and you're handed the keys to the turbine and all the responsibility is yours, how much do you really know about your turbine? And what I want to emphasize here is data ownership. Data ownership of CMS data. Depending on your contract with the OEM, you may or may not be entitled to copies of all alarm reports or historical data if CMS was factory installed. So again, I'm going to say it twice. Data ownership, data ownership. You need that data. Some things you might want to ask yourself who your service partners are. If you do not have the capacity to monitor the drivetrain of your turbines, ask yourself this. Are they independent? No conflict of interest here. These kind of questions might actually go in and affect your execution part if you want. You want unrestricted information. You want all that data, not part of it, not words here and there, not trends or plots or whatever. You just want all that data. You want local support. Without local support, you might risk low initiation. Again, this is all about the lead time. And last and not least, you want an experienced team. You want to be able to get that early detection. Yeah, not going to say much about that. So, final thoughts. So lead time, what does it really depend on? It's your strategy, it's the quality of your partners, and it's the knowledge that you have. So data, it leads to information, information leads to knowledge, and knowledge leads to wisdom. So when we take all this info and try to answer the question, what is lead time? How do we respond? So the benefits. Benefits are basically independent of who is behind the wheel. It's all about the turbine, and it does have a compelling value proposition. We did approximately 400 machine installation, and the time it took was approximately 3 months, and the payback on that investment was done, I believe, in 4 to 5 months. So CMS does bring instant business value, and it does have a quick payback. It's not that difficult. I was your presenter today, and I would like to thank you all for participating. And I think we can move on to some questions. Come on, guys, don't be shy. No questions. So one question here. Okay, lead time, of course, lead time on planetary states issues. I mentioned before that, you know, I've seen broken teeth run several months, and I've seen the same thing running in several weeks. So what is the strategy here? The strategy is basically to look at this fairly frequently. Not to mention if we're talking about planetary states issues. We don't really know how the load is going to be in the coming days, and if we knew that, we would probably be doing something else. But seeing as we don't know how the load variations are going to be, we cannot really predict when this gearbox is going to run to failure. So the best thing to do is to monitor very frequently, have an active team on standby, so to speak, get ready to jump up that tower and on a minute's notice, so to speak. Often it comes down to that. We can be talking about hours of response time, even, you know, sadly minutes. If a tooth comes off the planetary stage, there is no room for that huge debris to rattle around inside that it's going to chew up straight through that planetary stage. And if that happens, we might be talking about a very, very short time of running to complete failure. This is obviously something that we want to prevent, so it's all about being, you know, in that predictive maintenance, and how can you avoid catastrophic failure, and that is simply by being in front of the problem. And very often we're telling people to pull out bearings because we're starting to see other sensors in that on that gearbox being sensitive to that failure. You know, you might have 4 months left on that bearing, but for each month you run that bearing, you're going to reduce other components with let's say a certain number of time in remaining lifetime. So when do you justify pulling out a semi-healthy bearing just to save the other components? I mean, what is the real lead time here? I mean, it's all about understanding the machine, understanding secondary damages, understanding when it's the good time to pull that component out and replace it.
Rainier, do we have a little bit of time here to go into a gearbox case study?
Well, that was one that I just went through. If people are interested in knowing more, I would be happy to answer questions. Yeah, I don't know, maybe we should mention that here, the links, Maren, did you, we didn't mention that. There are some links here on the left side on the screen if people are interested in see a little bit of our achievements and what we're doing. I'm not sure if there are detailed case studies there with the spectral analysis and the frequency data, but there's some good stuff there.
Any other questions? There's quite a few of you who noted the gearbox. Certainly there's got to be a few unique things that have happened that you would like to present and get a feel on how CMS could have provided lead time to maintenance on that.
So here's one question. Can CMS detect pitch bearing damage? Yes and no. I've done it several times actually, but it's not always related to exact pitch bearing damage, and it really depends on the turbine type. If we talk about electrical pitching versus hydraulic pitching, these are two very different things in terms of the vibration signature acquired when things go wrong. Usually what we do for pitch bearing issues is that we monitor the, let's say the vibration associated with that main rotor. As soon as something goes wrong with one of those blades or the pitching, or you got a blade offset or pitch calibration issues, the dynamic loading from that rotor becomes, let's say, wrong. And this will manifest itself in elevated vibrations on that main rotor. So very often we pick up pitch bearing issues when we're looking at that main bearing and extracting data from our tower sensors. So can CMS detect pitch bearings? Yes. If you know what you're doing. So another question, where do you typically place your monitoring instruments and what type of instruments are they? Well, in our case, we got an online data collector which is mounted in the nacelle. So this is 24/7 data collection. And through the internet, we send all the vibration data. We send pre-processed and also raw data for post-processing purposes. So the instruments that we use mounted on the drivetrain are accelerometers with, let's say, different specifications based on the speed application. So we got different sensors mounted on the high-speed stage versus the low-speed stage. The sensitivity that we use on these sensors are both the same. These are 100 millivolts per G sensors. I am a strong believer that you do not necessarily need high sensitivity for low rotating parts. Of course, it's perhaps better, but it all comes down to the manipulation of data in the post-processing algorithms. So feature extractions from the time waveforms collected. If you ask me, it's all about the signal processing part of it, not necessarily the sensor type. So let's go through some of these questions. Can you give examples of what kind of data O&Os might be missing out and what they should be asking for? I got one example, and this is a part that was coming out of warranty. Just prior to end of warranty, 95% of the turbines in that park exhibit a step change on several different measurements distributed all throughout the drivetrain. And I couldn't figure out what was going on, but I had some questions that needed answering, and the owners and the operators, they approached the OEM. It turned out it was a software update done in the controller, but according to the OEM, this update was not supposed to change any performance. And to state the least, that was the last thing that happened, because I would say in some cases, vibrations jumped up with more than 100%. And it actually turned out that these turbines had been running outside the specification when we did the power curve analysis. So this update was supposed to accommodate for these incorrect specs that these turbines had been running all this time. So that's one thing, if you're not doing your own CMS, there are a lot of things that might happen that you will never hear about. If you're doing your own CMS, you can incorporate a lot of data from the SCADA into your CMS system. And I don't know if you have access to all those data points or not, but that is one thing, to make sure that you do have access to all that different information found in that SCADA system. But I would say, for the most part, if you're not doing CMS, you might be missing out on some very crucial information.
Next question is ownership of the data. Okay, go ahead.
Interesting. I was reading the same question, actually. So this is a good question. How do you handle the ownership of data when your contract partner is an OEM, especially when the owner of the VG is contacting you? So what the OEM has told me several times when we're doing CMS for those guys, because it's still under the warranty period, that all the data belongs to the end user. Now, when they say that, I presume it's because it says it in the contract. So this is something that you guys might want to look into. What does it say in your contract with the OEM? What kind of AOM agreement do you have? Because to my knowledge, this data belongs to the turbine owner.
We're getting a lot more questions on that these days, as everybody is looking to have that ownership of the data. With BKV, or B&K Vibro, our approach is the data is always owned by the individual contracting with us. In the case of an owner and operator, we can make arrangements to transfer that data directly to them. During the contract or at the end of the contract, we do not own the data.
Correct. I got one question here. Is BKV pursuing any non-traditional CMS approaches in research and development? Constantly. But everything costs money, and all good ideas have a price tag on it, so a lot of them get rejected. One interesting approach that I think, and that is audio techniques. Audio techniques. We're listening to all this raw data that is being collected by these accelerometers. And why are we doing that? And that is because of good communication with SAIS, which actually told me, and this is related to the pitch cylinder assembly for those that have hydraulic pitches. They were telling me that when they were approaching that tower, they could hear a knocking sound from down tower. So I thought to myself, well, if they can hear it, then I probably can hear it too. So what we did, we started sweeping the raw data and starting listening to it. We managed to isolate, let's say, that knocking sound that that technician was referring to. We managed to isolate it and create a customized measurement around that issue, so to speak. So every time we have a loose pitch cylinder now, we have 100% detection rate on that because we customized the special measurement just for that. So this is, again, when I want to emphasize the communication between the CMS provider and, let's say, the owner and the operator or the maintenance crew, because, you know, we might be your eyes and ears in places where you don't see, but you're definitely our eyes and ears in places where we do see. I mean, the guys up tower, they're doing, you know, at least half the job, if not even more. We're trying to guide them to a certain location, and based on experience, we try to put a severity estimation on it. But in the end of the day, it all comes down to what that technician sees and what he says and what are his recommendations on how to proceed. Should that turbine be in stop when he leaps? Should it be in run mode when he leaps? So that's not for the CMS specialist to decide, but that's for the let's say, the skilled technicians up towers. One question on sensitivity. I mentioned that a little bit before, but like I said, our sensors are 100 millivolt per Gs on the main bearing, on the planetary stage, on the generator, on the high speed. The only difference we do have is actually our tower sensor. That's 1 volt per G actually. There is a question here regarding cost of data ownership, storing in cloud versus buying servers. I have absolutely no idea. I think I'm paying like 5 gigabytes on Apple, and I pay, I don't know, $10 a month for it. No, I have honestly no idea what the cost associated with this data ownership is, but that's a very interesting question.
We have a number of customers that do take the data. They have it on their server, and nobody has complained about the cost. Data is relatively inexpensive these days, but the advantage is you have that data on your server forever. We also maintain data on our server, so it is never lost. And we're looking at condition monitoring technologies in the next 5 to 10 years. What do you see as the main challenges?
Well, for the past 5 to 10 years, we've been struggling and trying to define a grid monitoring template on the gearbox designs, right? And what we might see in the next 5 to 10 years that we're going to be with a gearbox without the gearbox design. If you ask me, that brings the current CMS solution available out in the market, that brings it a little bit down to a knee because that needs to be rethinked. We were asked here the other day to come up with a monitoring model or monitoring template or solution for a direct drive machine. And the only thing that made sense for that massive generator was to put in air gap sensors. Well, that pushed the price of a CMS solution from, several $1,000s to, tens and twenties of thousands of dollars, So already that was a showstopper because people think the prices of CMS solutions is already too expensive. So we couldn't really come up with a good solution for a direct drive without having to really alter the solution completely. So there we would have to look into different technology, and these technologies, they might also apply for the gearbox designs wind turbines. And, another thing we're seeing is the new 8 megawatt turbine coming from Vestas. It has a gearbox, but it is not let's say, a high-speed application. So our current OEM CMS solution for them would have to be altered based on that design. So every time the designs change, the designs become bigger and components become more complex, you need to rethink your monitoring strategy and hence the solution you have implement it in your CMS program.
I think as the turbines get bigger, they become more expensive, and your downtime is costing you far more lost revenue than ever before. So there'll be that much more pressure to bring those machines back online. CMS will be challenged to provide continued diagnostics for the larger machines and to further help the owners, the operators, address these developing issues.
What's the future of CMS? I would like to say it's bright. I strongly believe the future of CMS is bright. Technology-wise, well, like I said, if we go back those 7 years that I've been doing that, you know, we have really increased our skills. We have really learned to define our lead time and our diagnostics and the recommendations associated. And this is all done with the same technology. It's kind of like, you know, work smart, work hard, but before you can work smart, you need to work hard. You need to understand what you're doing before you're going to implement that in some kind of other technologies or even, you know, data mining. You know, there is so much data out there, you know, and do you really have the time to go through all that data, you know? We, for instance, we really don't have time to go through all this data that we already have, but this is something that we are constantly talking about. We need to look more into it, and because, like I said, is it all, do we need new and better technology, or just do we need to get better at what we're doing currently? And I believe a little bit in both.
Let me apologize. We passed up one of the questions a little bit earlier, and that was, is BKV a CMS provider? Yes. We provide condition monitoring services, onshore, offshore. We do this globally. We also manufacture and sell the equipment, all of the hardware necessary for CMS. Sorry if I wasn't clear on that earlier. Rainier, can you talk about the PLC question here?
Yeah, I was kind of like trying to answer that before. Do we currently exchange data with the PLC? We do not in the current solution. We do have, we are, however, we are equipping other transducers to our data collector to start collecting other sets of data. This can be, I mean, all kinds of different transducers. Whether or not we're connected, well, the PLC, we are extracting actually some controller values in some applications where we can trend on different controller values. One interesting parameter that we do trend on, and that is the nacelle direction given up in degrees. This enables you to do a rose map, which is quite interesting because you can eliminate, let's say, mechanical issues in your drivetrain, and the root cause of these elevated vibrations that you're seeing are due to the, let's say, the side topology. You know, is this turbine now in front of the other turbines, or is it behind the other turbines and exposed to a lot of turbulences? And this can actually create a lot of high vibration signatures in your drivetrain. But troubleshooting up tower for a fault like that, you're not going to find anything because it's not related to the drivetrain itself. So there are a lot of good parameters and data that you can fetch from other systems. But again, you need to just understand what kind of data it is and what are you going to do with it, because you can so easily drown in data that you're just going to be overwhelmed and lost.
So we have a question here on how we achieve or define 24/7 monitoring. And basically with 4 monitoring centers, our Chinese office comes online first in the morning, and as they're starting to close up for the day, our Narrum office is coming online. And then as they start to close, our Houston office. Basically what we have is a 24/6 monitoring with somebody in front of the screen. But our system is continuous online, and that is working 24/7. Rainer, could you talk a little bit about how we prioritize alarms?
Absolutely. It's not going to be a quick explanation, but I'll try my best here. So our system is a symptom-based system, and we kind of like define the different failure modes based on symptoms that we expect to see through different measurements that we have created in our system. So depending on which measurement are actually going into violation, the system is going to do, let's say, an estimation of that severity. Now, this severity will have an associated lead time with it. And as these, let's say, these faults starts to progress and develop over time, more and more measurements will then go into violation and then creating a higher severity and thus reducing that lead time. These are all guidelines, obviously. Nothing is equal to an exact time, let's say that. So again, what we try to do is we try to stay a little bit aggressive on it. We try to upgrade these alarm reports, reduce the lead time every time we see a reaction in the system. What we also do is we rely on other sensors on that drivetrain to see if we can pick up that same fault with more than one sensor that gives us an idea whether or not we're talking about a early local defect, if you want, or whether or not we're talking about a, let's, for the lack of a better word, a global defect, which is now affecting other components in your drivetrain. So there are different ways to achieve this, but all in all, what you need is a set of eyes in front of the screen, looking at that data 24/7.
Rainer, if somebody comes in and China sees a fault, starts to run it to ground, and doesn't quite finish it or still has some concerns, they may put a note in the system, and that'll be picked up by the NIRM office, who's coming in next.
Well, worst case scenario, they're just going to call us up or even drop us an email saying, please monitor this turbine very closely because we got a severity upgrade in the system and we're going home. So you guys, you take over. And the same goes for us. If we suspect something, especially when we're coming into the weekend, if we suspect something that doesn't look very nice, we give the Houston office a heads up. It's like, guys, you gotta keep an extra eye on this one. So it's all about the communication between our offices and obviously also with the client. You know, every time we see these, let's say, these state changes in the progression, if you want, it's not enough just to talk internally of what it means and how we should react. We need to inform the customer because he might also have other plans. So the sooner we get the information to the customer, the better.
Well, let's see if we have any more questions here. Oh.
So one question is, do we have experience with other brands than Vestas also? Well, if the question is if we have experience with more than just Vestas turbines, then the answer is yes. We do monitor GEs, Suslons, Senvions, Gemesas. Am I missing something? And obviously Vestas. So we
yes, and
yeah, we do have different platforms online. Yes, we do. But you know, when we really break it down, what's inside that turbine? You see Moventus, you see Hansen, you see Winenergy, and you see this in all the different platforms. So it's not so much. It is a little bit. It's not so much the turbine type, but it's more what kind of components are installed there because we see different. Let's say pattern behavior between, let's say, Moventus and Winenergy. You know, some gearbox manufacturers they have a gear issue, others have a bearing issue. Some platforms they suffer more on the generator, others suffer more on the main bearings. You know, what it comes down to that these turbines they have a personality, and that's what CMS is all about: is to define that personality and have the correct setup and the good monitoring strategy for that personality.
I think another question here is, how do you get our system? Well, we can be factory installed by the OEM, or if you have an older farm and CMS was not included originally, it can be retrofit. So there are many options available, and you can call me, Myron Hyzak, or my counterpart, Jeremy Ernst, And we'll be glad to talk further with you and develop a budgetary quotation. But CMS is a very mature topic. It is becoming very popular these days. Wind farm owners don't want to operate without it. Your PPA contract penalties are becoming more severe, and uptime is becoming critical. With the cost of parts going up, cost of maintenance, CMS is here. If we could help you in any way going down the road, if you have a question that's technical, Rainier is available, or if it's sales related, Byron or Jeremy. Is there any other questions before we sign off? Let's see. Rainier, any last comments you want to make?
No, I think I'm actually pretty good here. Just want to take this opportunity and thank everybody that participated.
Yes, thank you all.